In the Science Mission Directorate, SMD, the Astrophysics Division studies the universe. The science goals of the SMD Astrophysics Division are breathtaking. We seek to understand the universe and our place in it. We are starting to investigate the very moment of creation of the universe and are close to learning the full history of stars and galaxies. We are discovering how planetary systems form and how environments hospitable for life develop. And we will search for the signature of life on other worlds, perhaps to learn that we are not alone. NASA's goal in astrophysics is to discover how the universe works, explore how it began and evolved, and search for life on planets around other stars. Three broad scientific questions emanate from these goals. The astrophysics current missions include three of the great observatories originally planned in the 1980s and launched over the past 27 years. The current suite of operational great observatories include the Hubble Space Telescope, the Chandra X-ray Observatory, and the Spitzer Space Telescope. Additionally, the Fermi Gamma Ray Space Telescope explores the high-energy end of the spectrum. Innovative Explorer missions, such as the Swift Gamma Ray Explorer and Nuster, as well as Mission of Opportunity NICER, complement the astrophysics strategic missions. SOFIA, an airborne observatory for infrared astronomy, is in its operational phase and the Kepler mission is now actively engaged in K2 extended mission operations. All of the missions together account for much of humanity's accumulated knowledge of the heavens. Many of these missions have achieved their prime science goals but continue to produce spectacular results in their extended operations. NASA-funded investigators also participate in observations, data analysis and developed instruments for the astrophysics missions of our international partners, including ESA's XMM Newton. The near future will be dominated by several missions. Currently in development, with especially broad scientific utility, is the James Webb Space Telescope. Explorer mission TESS is also in development. TESS will provide an all-sky transit survey, identifying planets ranging from Earth-sized to gas giants, orbiting a wide range of stellar types and orbital distances. Also in work are detectors for ESA's Euclid mission. Completing the missions in development, supporting the operational missions, and funding the research and analysis programs will consume most of the Astrophysics Division resources. In February 2016, NASA formally started the top ASTRO 2010 decadal recommendation, the Wide Field Infrared Survey Telescope, WFIRST. WFIRST will aid researchers in their efforts to unravel the secrets of dark energy and dark matter and explore the evolution of the cosmos. It will also discover new worlds outside our solar system and advance the search for worlds that could be suitable for life. In January 2017, NASA selected the new Small Explorer (SMEX) mission Imaging X-ray Polarimetry Explorer, which uses the polarization state of light from astrophysical sources to provide insight into our understanding of X-ray production in objects such as neutron stars and pulsar wind nebulae, as well as stellar and supermassive black holes. In March 2017, NASA selected the Explorer mission of Opportunity GUSTO, Galactic Extragalactic ULDB Spectroscopic Terahertz Observatory, to measure emissions from the interstellar medium to help scientists determine the life cycle of interstellar gas in our Milky Way, witness the formation and destruction of star-forming clouds, and understand the dynamics and gas flow in the vicinity of the center of our galaxy. Since the 2001 decadal survey, the way the universe is viewed has changed dramatically. More than 3,400 planets have been discovered orbiting distant stars. Black holes are now known to be present at the center of most galaxies, including the Milky Way galaxy. The age, size and shape of the universe have been mapped based on the primordial radiation left by the Big Bang. And it has been learned that most of the matter in the universe is dark and invisible, and the universe is not only expanding, but accelerating in an unexpected way. For the long-term future, the astrophysics goals will be guided based on the results of the 2010 decadal survey New Worlds, New Horizons in Astronomy and Astrophysics. The priority science objectives chosen by the survey committee include searching for the first stars, galaxies, and black holes, seeking nearby habitable planets, and advancing understanding of the fundamental physics of the universe. In 2016, the New Worlds, New Horizons, a midterm assessment was released. In 2012, the Astrophysics Implementation Plan was released, updated in 2014 and again in 2016, which describes the activities currently being undertaken in response to the decadal survey recommendations within the current budgetary constraints. The Astrophysics Roadmap Enduring Quests, Daring Visions was developed by a task force of the Astrophysics Subcommittee, APS, in 2013. The roadmap presents a 30-year vision for astrophysics using the most recent decadal survey as the starting point. Work on the upcoming 2020 decadal survey has commenced. Please visit the 2020 decadal planning page for additional information about the large mission and probe mission concept studies currently underway.